In this video, we're going to find out what the derivative of inverse tangent is. Now, hopefully you've seen the ones for inverse sine and inverse cosine. This one's actually a lot more pleasant. So here the question we're going to answer is, if y is equal to tangent inverse of x, then what's the derivative? You're going to need the derivative of tangent is secant squared, right? The derivative of tangent of t with respect to t is secant squared of t. And we'll need this Pythagorean identity. And this is sort of an unusual one. It's hard to remember, so I don't remember it. Here's what I do. How do you remember this? I don't. I just start with this one. Start with sine squared theta plus cosine squared theta is equal to 1. And you can divide by cosine squared theta on both sides. And then this will simplify. This thing turns into tangent squared theta. Here this will turn into a 1, and then this is secant squared theta. And this is the formula that we're going to need. So instead of memorizing this, you can always just derive it from here by dividing by cosine squared theta. Now we're not going to need the formula that appears down here, but we have some time. Might as well derive it anyway. In the same way, start with the standard Pythagorean identity. Instead of dividing by cosine squared theta on both sides, divide by sine squared theta on both sides, simplify, and you'll get 1 plus cotangent squared theta is equal to cosecant squared theta. So the best thing to do, I think, is don't memorize this formula or this formula. Just start with this and realize all you have to do is divide by cosine squared or by sine squared theta. Okay? All right, but we are going to use this particular formula to get the derivative of inverse tangent. So start with y is equal to tangent inverse of x. Do what an inverse function does. It swaps the role of input and output here. Take the derivative on both sides with respect to x. On the right side, you'll need implicit differentiation, and then solve for dy dx. The usual problem is here that the derivative formula you have has a y. We're going to fix this by introducing this Pythagorean identity. Okay, right here, all we're going to do is rewrite the secant squared y, just swap the order of the two sides here really, and just put this tangent of y in parentheses. It's just emphasizing what tangent squared y really means. It means tangent of y quantity squared. And now tangent of y, that's right here. Replace that with an x. So if you just rewrite this thing says secant squared y is, and there's a replacement. Tangent y is replaced with x. And you have x squared plus 1 right there. All right. And then in the last step, all you do is take this formula and rewrite the denominator, secant squared y, replace the denominator with x squared plus 1. So the derivative of tangent inverse of x is 1 over x squared plus 1.